Now here in example 7, there's really not anything for us to do, but we just need to notice something very important. They've drawn for us the graph of a function here and the graph of its inverse, and they've also drawn a dotted line where the identity function would go. This is the line y equals x. Remember, we called that the identity function. Notice that the graph of a function and its inverse forms a mirror image across the identity function line. So compare the right side of the line to the left side, and you'll see that it's a mirror image. Let's look at this second graph. The function f is here, and its inverse function is here. Notice that these two graphs form a mirror image across the line y equals x. So any function and its inverse, when graphed on the same set of axes, are going to form this mirror image across the line y equals x. That's how we can look at two graphs and tell if those two functions are considered inverses or not. So here we have several pairs of graphs graphed on the same coordinate system, and we have the line y equals x. And the question for each of these is, do these two functions represent a pair of inverse functions or not? Okay, so looking at this first one and looking at the line y equals x, I can see that what's on the left side of the line y equals x is a mirror image of what's on the right side. So I would say that these two are inverses. And looking at the second pair of functions, here is the line y equals x, and I can see that the right side of the line is a mirror image of what's on the left side of the line. So these are inverses. When I look at this third pair of graphs, and I look at the line y equals x, what I see on the right side of the line is not a mirror image of what's on the left side of the line. So these two are not inverses. And also when I look at the fourth pair, what I see on the right side is not a mirror image of what I see on the left side. See, the mirror image of this part would have to be here, and it's not. And the mirror image of this part would have to be here. And so these two are not inverses. They do form a mirror image, but they form a mirror image across the y-axis, not across the y equals x line. So these two are not inverses. So now let's recap a little bit and collect some important facts about inverses. First of all, if f is 1 to 1, then f inverse exists. Second, we know that the domain of f is the range of f inverse, and the range of f is the domain of f inverse. Also, if the point a comma b is on the graph of f, then b comma a is on the graph of f inverse. Remember that the inverse function simply swaps the x's and y's. So the graphs of f and f inverse are going to be reflections across the line y equals x. And we can find the equation for f inverse by replacing f of x with y, interchanging the x and y's, and then solving for y, and then we can attach the label f inverse. Now we're going to look at example 8, which gives us a function f of x equals square root of x plus 5 for x greater than or equal to negative 5. And they tell us that f is 1 to 1, which means it will have an inverse function. Now we're going to do a few things. First, we're going to find the inverse function for f of x. Then we're going to graph f of x and f inverse on the same axes. This may not be something you would be asked to do on a test, but I think it will be helpful for us to see how these two graphs look together on the same coordinate system. And then we're going to give the domain and the range of f of x and f inverse of x. Let's start by finding the inverse of this given function. So we will replace f of x with a y, and now we will switch the x's and y's, and now we'll solve for y. So we'll square both sides to remove this radical, and that will give us x squared equals y plus 5. Now we will isolate the y, so we'll say minus 5 on both sides, and now we will replace y with f inverse, and so we have f inverse equals x squared minus 5. Now notice that our function that we got, our inverse function, is not a one-to-one function, so we'll have to think about that in just a minute. If it's not one-to-one, it can't have an inverse, and we know that our function's inverse is supposed to be this. So we'll have to address that in a minute. But first, let's graph f of x and f inverse of x on the same coordinate system. We'll start by plugging a few x values into our f of x function. Let's make ourselves a table. And since they said x has to be greater than or equal to -5, I'll just start with -5. And now you know why x has to be greater than or equal to -5, right? Because if we let x be less than -5, we would have a negative under the radical and our y values would be imaginary. We can't have that. So x is limited here. So let's plug in -5. -5 plus 5 is 0. The square root of 0 is 0. And then I went to -4. -4 plus 5 is +1, and the square root of 1 is 1. And then we have -1. -1 plus 5 is 4, and the square root of 4 is 2. And then we have 4. 4 plus 5 is 9, and the square root of 9 is 3. And you notice that I was careful to choose x values that were convenient to plug into our function and made it easy to get whole number y values out. So now let's plot each of these. Here's -5, 0, -4, 1, -1, 2, and 4, 3. And so our graph of f of x has that square root of x shape. It's just been moved over to the left 5 places. And now let's look at our inverse function. We can plot the inverse function by just reversing the x's and y's here. So let's graph 0, -5, which is here, 1, -4, which will be here, 2, -1, which will be here, and 4, 3, which is here. And you'll see that our graph goes this way. Now notice that since our f of x function can't have any y values that are less than 0, our inverse function can't have any x values that are less than 0, because if it did, the function wouldn't be one-to-one. If we allow any x values that are less than 0 here, you can see that the y values we get will form the other side of the parabola, which would make our function not one-to-one, which would keep us from having an inverse function. So the domain of f inverse needs to be limited so that x is greater than or equal to 0. That makes it a one-to-one function, because then each y can be produced by only one x value. Now let's write down the domain and the range of both of our functions here. The domain of our f function is from -5 to infinity. And the range of this function is from 0 to infinity. Remember, range is lowest y value to highest y value. And now, if we just take these two intervals and switch them, we'll have the domain and range of our inverse. The domain of f inverse is going to be 0 to infinity, and the range of f inverse is going to be -5 to infinity. Notice that the domain of f becomes the range of f inverse, and the range of f becomes the domain of f inverse. That's always true of a pair of inverse functions. And you can look at the graph of f inverse and see that that's true. The domain goes from 0 to infinity because we limited it that way to keep our inverse one-to-one. And the range of f inverse goes from -5 to infinity. Now let's take this function, which is one-to-one, and do the same thing that we did on the last example. First, we're going to find the equation for the inverse. So we'll start by replacing f of x with y, and we'll switch the x's and y's, and then we'll solve for y. So we're going to add 2 to both sides, And now we're going to take the cube root of both sides. That's going to give us cube root of x plus 2 equals negative y, because remember the third root of a negative is still negative. And now let's solve for y. So I've divided both sides by negative 1, and so I have negative cube root of x plus 2 equals y. And that means f inverse of x equals negative cube root of x plus 2. Now let's plot these two functions, and I'm just going to pick a few x values to plot. And remember, this is not something you would be asked to do on a test. You would not be asked to graph these two functions from scratch. But I'm just going to choose a few x values and plug them in, and we'll get sort of a rudimentary graph. So if I choose x equals negative 2, then negative 2 cubed is negative 8. And negative 8 minus 2 is 6. So I've plotted here negative 2 comma 6. And now let's plug in negative 1. Negative 1 cubed is negative 1. Negative 1 is positive 1. 1 minus 2 is negative 1. And now we'll plug in 0. 0 minus 2 is negative 2. And now we'll plug in 1. 1 cubed is 1. Negative 1 minus 2 is negative 3. And now we'll plug in 2. Negative 2 cubed is negative 8 minus 2 makes negative 10, which I've just put down here. Okay, that gives us this graph. This is the graph of negative x cubed minus 2. And now let's take each of those ordered pairs and swap them to get our graph of f inverse. And so you can see that this is the graph of f inverse, and all I did was swap the ordered pairs that we used to graph this one. So look at our y equals x line, and you can see that we have that mirror image across the y equals x line. And now let's give the domain and range of each of these functions. So the domain of our f function is from negative infinity to positive infinity, and the range is also from negative infinity to positive infinity. And for f inverse, we'll just swap these two, even though they're identical. The domain of f is the same as the range of f inverse, and the range of f is the same as the domain of f inverse. So the domain of f inverse is this interval, and the range of f inverse is this interval. And you can see when you look at the graph that the domain of f inverse is indeed negative infinity to positive infinity, and the range is also negative infinity to positive infinity. And we have one last function we're going to look at. This one is f of x equals 2 over x. This is a one-to-one function. We want to find its inverse, graph f of x and f inverse on the same coordinate system, and give the domain and range for both functions. So first, let's start by taking f of x equals 2 over x and replace the f of x with a y, and then swap the x and the y. And now we'll want to solve for y. So I'll multiply both sides by y and divide both sides by x. And look, this function is its own inverse. So I'll now replace the y with the f inverse notation. So this is a function that is its own inverse. Let's plot it. So I'm going to plug in x equals negative 4. So if x is negative 4, then y is 2 over negative 4, which is negative 1/2. And then I'm going to plug in x equals negative 2. So y would be 2 over negative 2, which is negative 1. And now I'm going to plug in x equals negative 1. So y is 2 over negative 1, which is negative 2. And now I'm going to plug in negative 1/2. So 2 divided by negative 1/2 is negative 4. And you see that I can't plug in x equal to 0 because that will make my function undefined. So now if I skip over to x equals positive 1/2, 2 over positive 1/2 is positive 4. And now if I plug in 1, 2 over 1 is 2. And if I plug in 2, 2 over 2 is 1. And if I plug in 4, 2 over 4 reduces to 1/2. So we have a y value of 1/2. This is a hyperbola, and it has a vertical asymptote at x equals 0 and a horizontal asymptote at y equals 0. Now we know that f and f inverse are the same function, so the graph of f inverse would just lie right on top of the existing graph of f of x. So I'll just draw over it in red like that. And now let's compare that to our line y equals x, and notice that the left side is a mirror image of the right side. So these do look like inverses. This does look like a function that would have to be its own inverse. And now let's give the domain and range of each of these. Remember, domain is all the x values. So looking at the graph, I can see that the domain of f of x is from negative infinity to 0, not including the 0, and then from 0 to infinity. And the range is from negative infinity to 0, and then from 0 to infinity. And notice that I have parentheses here on the zeros, because if I put brackets, I would be including the 0, which I'm really trying to leave out. So we need parentheses on the end of our intervals. And of course, the domain and range of f inverse would just be these two intervals swapped. This one is the domain of f inverse, and this one is the range of f inverse. Now I want you to think back through all that we've done in this section. This is really a very large section with a lot of important information in it. We started out by talking about one-to-one functions, and then we talked about how to tell if two functions are inverses of each other, and then we talked about how to find the inverse of a function, and we talked about what the graphs of inverse functions look like, and we talked about the domain and range of a function versus its inverse function. So you've got a lot to think about and a lot to work on in this section. So I hope you'll spend some time, ask questions if you need to, give yourself time to think about things and to read back over, because it really will sink in the more you think about it. But it takes practice for it to really stick and become something that you deeply understand. So good luck.